Okay, here we go. Two-dimensional arrays. We're gonna finish up chapter 7 right before spring break, which is next week. We're gonna talk about two-dimensional arrays. We just talked about arrays, nothing new. We're gonna talk about two-dimensional arrays like you had back briefly in CPS 121. And there actually is one thing that's new. So two-dimensional array has two dimensions. We had one before in square brackets, 0, 0. We now have two sets of square brackets. And I can't remember if it's this or Java that you can just do 0, comma 0 inside of square brackets instead of separating them. Not sure. Stick with the square brackets though. Quick review from before. Uh, First index is 0, second index is 0. Pascal is the only language I know of that actually starts at 1 for all this stuff instead of 0. But I could go grab my, I already wrote the answers on there, my 121 notes and put, how many times does this loop run for this and how would you get the subscripts you want? But let's take a look at code listing 721 instead. What is the one new thing that you didn't have to do in Java that you have to do in C++? What is it? We got the declaration. We have the two dimensions, 3 rows, 4 columns. We know what kind of numbers we want to use. You type this guy up, and it was kind of boring fun, but you typed in all these numbers and wondered why you didn't change it and make it 1 to 2 and 1 to 3 and then 1 to 2 or something. Typed in all those numbers. That wasn't any kind of big deal. The big deal came in 722. When I get ready to do a prototype, unlike a regular array where I have an empty subscript in my first square brackets, my second set of square brackets must contain a size. So as far as what's going on here, that's what's new in C++. We have a nice implicit initialization going on here. When I get ready, I bring in the address of the array. When I bring in the address of the array for numbers, I have square brackets, but I also need this size. And you notice this size comes along in with it. Here's rows, the number of columns comes along. So it's a slight modification. So if you're doing a program, you got something going that looks like that. You have to remember to pass that second dimension.
So we could pass both the first and the second. It's just we have to pass the second.
No, you cannot pass the
We
first.
cannot pass the first. And
No,
that's why int rows is a thing there because that's then inserted.
yes,
Okay,
yes, you
got
have
it.
to
Thank you.
include that as well. Yep. So if I said to you, cool, let's write da 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 an algorithm because you're good at algorithms. I don't even think one was included in this last program, but some of you still included it. Shooby dooby doo. Tac toe. You got it? Write a program to play tic tac toe. Write an algorithm. Where would you start? What would your conversation be? Well, we're
You mean
going to
like
use
with
it,
the user?
but yes, the computer versus or two users or whatever you want. Two users. Good question.
Uh, First, oh, two users, not the computer. If it were the computer, I was going to ask the user if they wanted to go first or second. If it's the users, they can kind of decide that on their own.
Stack it up a little bit because you're here. I'm back up here, and I need to talk about. Well,
Oh, the
let's go
array, like 3 by 3 array. Okay.
a two-dimensional array. Good size, 3 by 3. Good subscripts. I know they're going to go 0 to 2 and 0 to 2. And this guy is 0, 0. But how are you going to ask the user? This guy is row 0, column 1, row 0, column 2. This is 2, 2. But if I said to you, hey, Nicholas, oh, what's the first question would be? Who goes first? Nicholas, you're going to go first. What's the one thing I need to know from you?
Where do I want to put my first placeholder or like X or O?
And what would you, oh, X or O? That's a good question.
X goes first.
X goes first.
I'm pretty sure that's a rule.
So once we get into talking about this, it's a matter of let's write all these things down as quick as possible. And we might need to keep track. We'll have a variable called X or O that is a char. So we can, X or O has the value of X. So the next move goes, an X is placed there, and then we change it to an O. Just starting to come up with, if you and I and two other people were in a group, how would I get to start it? So I'm asking Nicholas, where would you put this, Nicholas?
Where would I put the
Your X.
which part? My X?
Yeah.
I'd maybe assign it like top left, middle left, right left, and then like left, middle, right, and then bottom
Right.
left, bottom right. And that would, kind of translate it that way.
Dumb it down. Dumb it down for Joe Schmo. Where would you like to put your X? How many choices are there?
9.
9. Um, 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty good way to dumb it down.
Okay.
Yeah. I'm done picking on you, Nicholas. So anybody after this, you just happen to be up on the screen. So I'm going to say, okay, so and so, your X, where would you like to move? Boom. X goes first. And a big fat X goes right there. Oh, how do I know it goes right there? Can it go right there?
You would need to check if there was already a value at that spot. Going first, it wouldn't be an issue, but moving forward, you don't want to let the next person overwrite an O there.
Function. Check available. Right, so we put the X in. This guy's going to switch from an X to an O. Oh, what else should I do after I check it's available and put an X in? Because I may have to re-ask while I'm in here. I'm sorry, that one's not available. Please choose another number. How would I display this? I'm going to need a function to display the board. I'm scribbling tons of stuff down before I even start typing this because, okay, so we went, Nicholas, you chose an X. I checked to see if it's available. It was. I didn't have to re-ask. I displayed the board. What else should be going on there?
A check to see if the person has won after that move.
All right, check if it's a win or not. Cool. Check for a win if it's not. If it is, we need to get out of a loop. Why are we in a loop? Well, we need to loop around until more notes. Loop until what?
Until win conditions met.
We have a winner.
Could we set like, as far as the win condition, position 1 equals position 5 equals position 9, and then the other ones?
Yeah. Under in my check win, how many different ways can you win?
8?
8 ways. Check win 8 ways. Ooh. I'm in my loop until we have a winner
Or a draw.
or a draw. Yeah. So I'm gonna have a while loop that oh, I might make this winner a whatchamacallit, a what's that called?
Flag.
A flag. Yeah. True or false? The draw means there were 9 moves. Maybe I have something like this going. Num moves equals 9. Ah, there's my while loop. While winner equals false, and
Moves less than 9.
yeah, num moves is less than 9. Starting to put some code together. Then I'm going to do all kind of crazy stuff. So I have my before loop. What's my after loop going to look like? While that I'm right here talking about this, an if statement. If
A statement
If
on the
Go
win
ahead.
results. If it's a draw, if player one won, yeah, and player two won.
num moves equals so they could win on the 9th move, right? So I have to be real careful how I do this. If num moves equals something, display draw.
Would it be wiser just to put the num moves second, like in an else if statement or just an else statement, and to start with
Okay.
the 3 in a row condition?
Mhm. And I'm doing the algorithm. So when I'm down here now, I'm starting to create a loop. All kind of stuff's going on in here. I'm going to need some initial values. One of my initial values is going to be X or O, and it's going to equal X. We have check available, display the board, check wins. So if I said we needed to write this fast, I might now say we have a group project and just running left to right. Kyle, you're in charge of putting the main together. Hector, I want you to do this question, this function, check if it's available. And so we would cut and paste that. Andrea, I want you to have something to display the board. Okay. Nima, you're going to check the 8 ways to win. And, all of a sudden you're checking if 0, 0 is equal to, keep going. Man, that's kind of a long one. And I would need somebody to do some work to say, if they enter a 1, it's location 0, 0. If it's a 2, it's location. So we'd have to do that because we made it user friendly up here. So this little program would be a great group project. And if we met twice a week instead of once a week, I would now cut you loose on this. My point today was okay, here's the approach. We have this guy's name. I'm the leader. We all worked on this together. Display board or something. We'd have to come up with making sure our function names. So when Kyle was writing check avail, do you have any parameters coming in? Are we passing an array in or not? Are we turning? So all of this pre-work would need to be done on a whiteboard. Those of you, 90% of you, would probably start typing right away. I need to draw the picture. I need to, look at this process we went through. And there's t-shirts out there that say programming is thinking, not typing. Keep that in mind. But we had to do a whole lot of thinking before we went anywhere. So one, I need you to get in a habit of thinking first. You can't see that. And then the other habit I'd love to get you in is type, compile, repeat. Type some stuff up, compile it. That's good. Move on. Add some more. This is where a lot of you are stuck. Oh, okay. Finally compile and go, nothing works. Break it down into smaller pieces. Type and compile, type and compile, type and compile. Okay. Questions. Here's an old one. A little more of an algorithm. Initialize the board, display the board, move equals X. Okay, we talked about that. Count equals 0. We know we have that 9 count thing going. Winner equals false. So this is a bunch of upfront stuff. What am I repeating? We said winner not equal to true and count 9, 0 through 8. Get the move. This might be the next step that we put on the board before I sent people out in groups. We have the official names. We have on and on and on. If move was X, now make move Y. Else move equals X. There's my loop control variable being incremented. If I handed this to you, would it be much easier to work with? Yeah. Yeah. And I'm stating the obvious how this goes. But it's like in 121 when you had a UML chart, and I said, now create a class for this. You had your get length and get width, the set length and set width, and you had your constructors, and with all of that there, it became really, really easy to type. So yeah, good. Good. That's what we did today. Is that worth saving? I don't know if I'll save that or not.
I mean, if you've got a folder.
I do. I have 3-ring binders for everything. I'm a 3-ring binder kind of guy.
It's worth saving. It's a happy memory.
Then I actually threw my 121 binder away because it's been years since I taught it, and I get it the last semester. So I had to rewrite a bunch of stuff mid-semester, as some of you know, and then I had to finish it out. But anyhow, part 2 of day number 7. It's our 7th week of meeting. Next week is day 8. These things called vectors. All right. If I said I want you to store a bunch of values, you may get ready and say, I'm going to draw a picture for this, and I'm going to store some values, and I'm going to use an array because these are homogeneous. They're all the same data type. They're all integers, and I'm going to store them, and I can store 8 of them. And that's it, because I didn't know how many I was supposed to store. Okay. Static. And done. That's all I can work with. Now, C++ has an option, and it's called a vector. And a vector is something that is dynamic. Remember, this was array, and this was array sub 0 because we went 0 times 4 bytes times 4 bytes times 4 bytes, and 1, 2, 3, 4, 5, 6. So this was a sub 7, which means I went to the address array and I went out 28 bytes and I read the next 4 because it was an integer and I got that value. But I didn't know what was going on here. Well, the difference between an array and a vector is it'll let me keep going. It'll let me keep going. Now, is it good? Yeah, because it lets me keep going. Is it bad? Oh, yeah, because you can't keep going with an array, but there are advantages. Now, the array was nice, and it followed that. Go to the address and go 4 bytes at a time. Nice. Well, a vector said, we want to use this idea, but we're going to write special code that will allow us to keep adding on. or to keep removing back. And that's the whole idea of a vector. It's a class. So you know how we have our primitive data types: int, double, char, boolean. And then all of a sudden people were saying, well, I'd like to write something more than 5 chars in a row that spell a word. I want to create this thing called a string class, so that it's not a primitive data type. Hey, this goes to an address, as you all know, and it keeps going. But this had to be written. And when this was written, a whole bunch of functions were written to use it. Well, here we have an array, but in order to do a vector, we have to get all those functions to really get value of this vector versus array. Okay. I don't know what I just said. Hopefully it all made sense. Now, in Java, in C++, you have this standard template library. In it is string. It's a data type that's set up for us. Somebody wrote all the code for string. Somebody wrote all the code for vectors. And again, I had algorithm, it's functions. We're in C++ and we're talking about, but all of these classes are written. Now, it's a little more than a class, and in 162 you'll understand why, but it's called a data type. It's like an int, a real, a double, different types of ones. It's written by a programmer and it's built in. So there's lots of these libraries that are built in, and you see a lot of them with import statements. Okay, I didn't feel like writing all this down, but a quick comparison: vector is definitely like an array. It's a homogeneous list. We're storing values side by side in a sequence. Similarities include we can use the subscript if we want. So the person that wrote this current program like an array, you're going to have to, you have all the logic down. You just need to get it over to being an actual array. How does it different? You do not have to declare a size. It grows. And someone even wrote a function that says, oh, by the way, go find out how big that is for me. How many items are in there? And it'll go across. One of several functions that we could possibly be using. Vector, you're going to see these. I've heard them called lots of different names. What's around the word vector? I've heard them called diamond braces, because if you put them together, it looks like a baseball diamond. Caret brackets, or angle brackets. I've heard a bunch of different names. I think I usually call them diamond brackets. All right. As always, I'm including all the code that's there is about vector that's not normally included, because it would take forever to compile all of those files. What have we got going? Hopefully you read down through some of this and you saw, pardon me for 1 second, I got stuff everywhere. By the way, I am in section 711, and we get into this whole introduction to standard template library. One that's called vector. Starting out with this new data type, I have several different ways. I can declare a vector of integers and call it numbers. I can actually declare a size if I want. Earlier, we don't know how big we want it to be. We can start it out blank. We can say, I want at least room to store 10 integers. Here's something that's a little different. I could say, I want at least 10 integer in memory, and I want 2 stored in each one of them. here's another thing. I can copy everything in this vector to everything in this vector called set 2. It's almost like these are a bunch of, what do these remind me of? Having all these options. It almost reminds me of 2 words. But we're doing the same thing. We just have different parameter lists.
Oh,
Overloading.
Overloading, yeah. And it almost looks like I'm creating a constructor of sorts and overloading it. Right? I'm getting it ready and I'm saying, yeah, it's like a constructor. Yeah, different things going on there. Okay. Here we go, 724. It's code listing time. Shooby-dooby-doo. I need to flip that over, flip that over. I want to make sure my notes are in the right order. And if I could find them, that would be good. Let's take a look at what's going on here. 724. So I have a question, and you might not want to answer it because you don't want to be the one. A couple of you worked ahead. Did you type the code listings up before you did the program? Or did you attempt the program?
I think this was one of the few times I did the code listings first.
Then it made the program much easier. I mean, I think so. That's how I would have done it. You know, if I'm a student and I'm thinking like I'm the student and I'm getting ready to do a program on chapters or section 711, I'm going, no, wait a minute. Every time I type the code listings up first, I have a pretty good idea what's going on in class. Maybe I should do that now, even though you didn't have to. But let's see what we got. Declaration of 2 vectors. The first vector is an integer vector. The second vector is a double. We give them names, which we kind of know the name hours is really holding the
Number of
address.
employees.
It's holding the address.
No,
And
right.
hours is where we get started. And we're saying already I want to allot 20 bytes so I can store things. Okay. Here we go. Let's see what's going on. Baby steps with vectors. There we go. Baby steps because I'm using a vector, and this example is showing me the exact same thing I would do if I had an array, where I can go and put items in, putting them in, putting them in, putting them in. I can display items from a vector using subscripts. So really, this is nothing exciting. This is what we did with arrays. We're just naming them vectors instead. Okay? Again, nothing exciting. Range base, go the address. It knows its integers, the numbers, and it'll read it into val. Goes to the address, reads it in as vals. Nice. Boom, 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 boom. From here, it reads it into there. Did you notice this is a for loop? If you want to use them or not. Another example of range base. Go to the address, read in the reference value at that address. So here I created a vectors. Good, da 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 da. Reading values in, passing values out. I'm looking at Nima's screen. It looks like an EMP just went off. It's like a movie.
Yeah. Some troubles with my camera.
A simple example. This time I don't have subscripts and it's advancing 4 bytes at a time, reading it into val. Now let's get into some vector stuff, and that's where 727 kicks in. 727 starts us out with 2 empty vectors. Again, documentation is great. a vector of integers at the address hours, a vector double at the address pay rate. So I have two of them I want to, and I want to add items. Well, I don't really want to keep track of subscripts. I don't need to keep track of subscripts. Why? Because I'm going to use these two functions. I have a function called push. Push. Push back allows me to add an item. Read it in. I add it to the hours vector. I read it in. I add it to the pay rate vector. Nice. So now my vectors are filled. If I actually know how many there are, because I kept track of them, I can now go and access those values by using the subscripts if I'd like. In a minute, you're going to see we don't have to use the subscripts. But I'm filling this vector with pushback. Working with a vector and not a subscript. I want to just make sure this works. So right now I'm using subscripts with the vector to go through and access all of them. But if I didn't know how big it was, I have a function called size. Nice. In case I forgot, didn't we have string length? We had length for string we could use if we wanted to. We have size for vector. So it's written, it's similar to the way string was put together. Da, 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 da. Here we go. We're going to go through and I'm going to add 7 numbers to my vector. My vector is called values. I have a function called show values. I should underline this because that's new. How we pass a vector in through the function. And now, ladies and gentlemen, boom. This is how I make a part of the parameter list. And I come in and use size so that I can scroll through and print them out. Again, I'm still using the subscript. Excitement here comes removing elements from a vector. Boom. I now have pop back. Push and pop will come out in CPS 162. We'll talk about something called a stack. It's a data type. Okay. Push and pop. Pop. See what's going on here. I push 3 values on. 1, 2, and 3. And now I pop. Oh boy. Without looking at the next page. What do you think gets popped?
3.
The 3. It goes from the end and goes in reverse. If you want to go from lowest to highest, you might want to use the array subscripts. But pop removes from the end. And again, this is like a stack of plates. If I push the first one onto the pile, then I push down the pile and put the second one, or a Pez dispenser, and I keep pushing them on top. And then I want to take and pop from the end, that last one. So that last one in becomes the
First one
First
out.
one out.
yeah, that's something called LIFO.
When you said about if you want to get rid of the first one, use the subscripts, in what manner would you do that?
You would just read it.
Oh,
That's all I meant. Yeah. If you wanted to access it right away. But there's reasons to do this whole LIFO thing. You add to the end and then you delete from the end and so on. That's down the road. We're just learning about the idea of a vector. Okay, so we saw dot size. That was a function written for vectors. Check this out. Dot clear, another function that goes along with vectors. We have dot empty. Oh, there it is. to find out if it's empty or not. So a bunch of stuff is already written for us, and it's all ready for us to use. And even in the book, 448, boy, we have the clear, the empty, the pop back, the push back, resize. Oh, that's interesting. Swap, nice. Swap two vectors, whole bunch of different things going on. Left side, right side. What matches what? I made a little matching game. Shooby-dooby-doo.
Dot size goes with gets the number of elements.
Dot size gets the number of elements. Yeah. It's kind of silly, but it's there.
Clears all elements with empty.
Clears all elements with
Sure that isn't clear.
Clear. Yeah.
clear. Yeah. Yeah.
Pop back removes the last one.
Pop back removes the last one. Yeah. No, 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 no.
Value located at is at.
Yeah, that's one we didn't say. And I got to jump over those to get down there. Returns true if empty.
Empty.
Yeah. Adds to the end.
Pushback.
Pushback. Yeah. That would add to the end. Okay. I have two programs. We wrote Fibonacci sequence, correct? Did we do Fibonacci sequence?
Did anyone actually finish the program that we were doing before it? I think my group just finished it in time.
Well, you didn't
'Cause
do
we-
it? I mean,
We were
it
doing that
wasn't-
with another one, and I'm not sure if anyone actually got it done.
So then, if you had it done, it would be take the arrays, convert it into vectors using push and pop. Okay? Instead, I have this number 17 on page 459, name search. And we're going to work on that today. First thing I'm going to do is stop recording.